Hello, everybody. Welcome back. We're going to do our first part of lesson 6 from our unit 4. We're going to talk about what the three main trigonometric ratios are. We're going to learn about them. Again, they're ratios. They are basically values, expressions that are ratios, which are fractions. Um, and we are, again, going to learn those, but they all, and how they work with right triangles. So the key today is to understand that in a right triangle, we, of course, have our special angle, our right triangle. That's where it gets its name. But there are two other angles, okay? And those angles are in like different corners of the triangle, right? It's kind of like if you're standing in a room, if you and your friends stand in different corners, the way you view the room is going to be a little bit different. Um, and that's very important to understand because depending on where you are standing or depending on which angle you're looking at, the way that you describe the room will be different. The words that we use to describe the sides of a triangle are we use hypotenuse, which is easy because the hypotenuse is always across from the 90-degree angle. That's the one that doesn't change. Now, the ones that do change are the ones that we call adjacent and opposite. Okay, so the adjacent means next to, opposite means kind of opposite, furthest away. So have you ever heard the phrase, right? One man's trash is another man's treasure, right? It's kind of like that idea that depending on who you are, you're going to view things differently. So in this case, this picture here is describing everything based off of the vantage point of angle A. So from angle A's perspective, right? This side here, AB, is adjacent, meaning next to. Okay, that we would call it adjacent. Now you may say, well, the hypotenuse is also adjacent. Well, it already has a name, and that name is hypotenuse, so it doesn't need that name. Now, the opposite side, all the way over here, notice how it is not adjacent, right? The angle A, as it's created, does not use that side length at all to make its angle. So we use the term opposite. I always like to think too, like if you're standing in a corner, and you're like screaming out to the other side, which direction are you screaming? And that would be at this other wall, right? And with a triangle, right? There's one. If you're in a corner, there's only one way to look out from it, and that's at the opposite side. So that would change it would be very different if we went from C's perspective. We wouldn't call them opposite and adjacent. We would have to switch them. Now we'll get and talk about that later. But again, the big thing here is that we have to consider the angle we're talking about each time. There's not a simple, I just do this every time and I'm done. You got to think and process first. But once we have that understanding, once we know what angle we are talking about, okay, once we know, we are going to learn about the three trig functions, which are called sine, cosine, and tangent. Okay, quite simply, they are ratios that tell us different bits of information about our triangle. The sine function takes the opposite side of an angle and divides that by the hypotenuse. So again, if you take an angle like these blue angles up here, the opposite side, the furthest one away, divided by the hypotenuse, that represents the value of sine, right? If we moved the angle, it doesn't change how we find sine. It just changes which side lengths that we would use to calculate it. Again, sine kind of tells us how tall our triangle is in comparison to how big it is. Now, the way that I'll show you guys the way that we remember it at the beginning, but this is SOH is a way we can help remember sine opposite hypotenuse. Cosine is kind of how wide a triangle is based on its size. We use the adjacent side to the angle. So again, from our angle's perspective, where we are, so if we're this blue angle up here at the top, this side is adjacent. This side is the hypotenuse. Again, it's the side opposite 90. So we do that fraction, right? The adjacent side divided by the hypotenuse. So pretty similar to sine, right? Like they're both fractions and they both divide by the hypotenuse, right? The difference is the side length they use as the numerator. And then the last one, tangent. Tangent is the opposite side divided by the adjacent side. So notice this one doesn't use the hypotenuse at all. So from the perspective of this angle, the opposite side is this one, right? The one that it doesn't touch. And then the adjacent side is the one that the angle is next to, but it isn't the hypotenuse, right? So there's some subtlety here that you got to understand. But again, these trigonometric functions always represent these ratios, and they depend on the side lengths of the triangle. Now, you probably have heard maybe potentially at some point, there's this phrase that we used to use to memorize these ratios. It was called SOHCAHTOA. Again, kind of like think of like a Native American type word, right? Like, or just any foreign word. It's definitely not an English word, right? SOHCAHTOA. We see this as three little triplets, right? So SOH stands for sine opposite hypotenuse. CAH stands for cosine adjacent hypotenuse. And TOA stands for tangent opposite adjacent. Okay, so it's just a way to try and remember which pair of sides go with which one. Let me show you guys how this works. All right, so again, the big understanding here is that a triangle itself doesn't have a sine. An angle does. An angle does, right? So when I go here and I say I want to know, let's say the sine of angle A. Well, the sine of angle A depends on the location of angle A, right? The sine is the opposite over the hypotenuse. So the opposite side to A is 3. The hypotenuse is 5. That's it. The answer is 3/5. So what about the cosine of angle A? Well, the cosine of angle A is the adjacent over the hypotenuse. So the cosine of angle A in this case, the adjacent side is the side next to it that isn't the hypotenuse. That's 4. The hypotenuse here is 5. That's it. 4/5. And the tangent is the opposite side of the adjacent. So for A, that's going to be the opposite side, which is 3, over the adjacent side, which is 4. So that's it. These are what the trigonometric ratios are. The sine of A is a number. It is 3/5, 60%, right? Cosine of A is 4/5, or 80%. Tangent is 3/4, or 75%. These are all ratios that tell us something about the composition and the makeup of our triangle. Now, what if we looked at this from a different perspective? What if I said, hey, I want to go from B's perspective now? Right, this is a different corner. This triangle looks different if you're standing where B is. It's kind of like, if you are, like a basketball referee standing at mid-court or standing on the baseline is going to have a different view than somebody on the sideline, right? The rectangle, the court looks different. It's just in a different orientation, but it's the same court. But we do things the same way. If we want to find the sine of B, okay, the sine of B will be the opposite of B, which again is the side furthest away, which is 4. And we're going to divide by the hypotenuse, which is still 5. So notice how the sine of A and sine of B are different. That's because their adjacent sides are different. Okay? The cosine of B will also be different. The cosine of B will also be different because, again, the adjacent side of A and B are different. The adjacent side of B is going to be 3. And the hypotenuse will still be 5. In fact, you're always going to see a link like this. The sine of one angle in a right triangle will always be the cosine of the other. And so if you notice that pattern, that's always true because one angle's adjacent is the other angle's opposite. And then finally, tangent's actually just going to be flipped upside down for B. Because again, from B's perspective, we do opposite over adjacent. Well, we just swap them, right? So in this case, the opposite of B is 4 and the adjacent's 3. So again, we have to know the angle first. Remember, a triangle doesn't have a sine. It doesn't have a cosine. It doesn't have a tangent. Only angles do. So let's look here, right? So the sine of angle E, right? So the sine, we use SOH, which is the sine of an angle. So this little angle, this little thing here is called theta. It's a Greek letter. You don't need to worry about it, but mainly it's just kind of like an X. They just use it for angles a lot, so you'll see that. So it says, what is the sine of angle E? So we need to go from angle E's perspective, and we're looking for the opposite side and the hypotenuse. The opposite side is 30, so the sine of angle E, I don't need to read. Clear this up. The sine of angle E is going to equal, the opposite side is 30. Sorry, Canva's getting tired. 30 divided by the hypotenuse, which is 34. Now look at the answer conditions. It says write your answer as a proper fraction, improper fraction, or whole number. Again, I think you should be able to enter 30 over 34. It doesn't say to, oh, it does say to simplify, sorry. I should have jumped to that. 30 over 34, each of these numbers can be divided by 2. So this can be 15 over 17. Okay, so that would be the simplified version. And you may say, well, there's no 15 and 17 in the problem. Remember, these are just ratios. They're like percentages. So from E's perspective, right, the opposite side is pretty long compared to the overall size of this triangle. Okay, what about the cosine of angle T? All right, so remember, cosine is CAH. CAH. Okay, now this one throws us for a little bit of a loop, and we have to be very careful here because we can easily get confused here. But we start with, okay, we know what cosine is, right, of angle T. So if we look here, we have the adjacent side, but the hypotenuse is missing. This is a problem. Okay, this is a problem. So in order to go through this problem, we have to have the hypotenuse. There's no way around it. So the way that we can find the hypotenuse is by using the Pythagorean theorem. So the Pythagorean theorem says, and sorry, I need to do this, a squared plus b squared is equal to c squared. So if we plug in A and B, this would be 48 and 55. This makes C squared. So if we added these together, 48 squared plus 55 squared, you should get 5,329. 5,329, which if I take the square root of that number, I should get 73. Right, C again. This may happen again. You got to take the square root, right? Everybody always hates doing it, but tis a thing, and we get 73, right? So at this point, we've done all the heavy lifting, okay? So we're going to go back. We're going to take this number. We're going to say, okay, this is 73. Now we go back to what we've been learning. The cosine is the adjacent side over the hypotenuse. This is the adjacent side. This is the hypotenuse for T. Remember, the opposite side is the one where the angle doesn't touch, right? So we don't need that. So we're going to say here the cosine of T is going to equal the adjacent side, which is 48, over the hypotenuse, which is 73. Now, I'm fairly certain that these don't have any common numbers between them, pretty sure. And so this is the final answer.